All right, folks. Well, what I want to do now is to work through a couple of practice final exam questions. So this is going to be, okay, let's look at a question, see if we can figure out what an appropriate answer would be. And again, kind of from the perspective of this year's take-home exam. So this first question is actually taken from the 2016 final exam. So if you go to the course exams page, you'll find the link to 2016, and you can find this. This is one of the ones that doesn't have a sample solution, so this is one of the ones that I figured would be a good choice for today. So the original question is this idea of, here's a couple of chunks of code, one in Lisp and one in C, and we're supposed to be looking at this as if it was being handled by a two-stage compiler. And the idea was the first stage, it goes through and breaks this thing up into tokens the way we described earlier in the term. And then the second stage is to go through and do the syntax checking and whatnot. Again, the kind of Lex and Yak style of processing that we've been talking about. So the original question was to go through and pick either the Lisp or the C, and then say, okay, let's break it up, show the tokenization, and then explain what the output is. And so I'm going to tweak the question just a little bit to, I guess, better represent the take-home style of final exam. So I'll show you the tweaked question, and then we'll work through an answer for it. So the idea is here. Let's see if I can actually find the code for this. Yeah. And it's, you'd think I would have thought to do this before we set all this up, but here we go. So here's essentially the tweaked version of the question. So this is more the style I would expect for a take-home exam, more like what you're going to get. So in this one, we've taken out the Lisp part and just made it, you have to do the C version. It's essentially the same idea. We're supposed to go through, and here's the program. We're supposed to tokenize it. And then we're supposed to go through, and this time I actually tell you, since this is take-home anyways, and you can compile it and run it yourself, the program winds up returning the value 3. Your task is to explain why. And it's based on what you know about precedence and associativity and the way you tokenize this. So if we come up with a reasonable tokenization, we can figure out what's going on. So I just want to go through, and we'll tackle the first part first. Surprise, surprise. And again, the idea is we want to go through and tokenize this. So we just want to break it up into the list of tokens that the compiler would be dealing with. So this is just breaking it up into the key components. And this should be pretty mechanical by this point. So all I'm going to do is just, what's an easy way to do this? I'm just going to, do we have any commas in there? There's no commas in this program. Oh, there's one. Okay, well, what I'm going to do, I'm just going to show the tokens as a comma-separated list. One big, long comma-separated list. So I'm just going to go in here and stick a comma in. So maybe I'll stick a note in here. Sample solution showing tokens separated by commas. So all I'm going to do is go through and stick a comma after everything I think is a token. Right? No big surprise, just every variable, every symbol, right? Every identifier. Now this next spot is the first spot where it actually gets a little bit tricky, because we're looking at this going, okay, y plus 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 2, what is it going to take that as? Well, when the compiler is going through, or when it's going through and tokenizing this beast, it's going to have to look at it in some sort of a logical context. And my expectation would be that it can't possibly be thinking plus plus 2, because you can't go through and pre-increment a constant. So it's got to be taking this as a plus plus on the y0 pretty much. So I'm going to kind of guess that that's the way things are going. It's going to break it up like this. So maybe I even stick in a note there. You know, I'm presuming that plus is tokenized as plus comma plus, something like that. So I'll go through and make a sort of reasonable interpretation of what I think this all is. Alright, so just all these tokens that we've got in here. And again, pretty mechanical. And I'm just going to split this up with a white space. The only place where I guess the notation of the answer might get a little confusing is where we actually have that comma in there, but I'd be kind of anticipating that when I was looking at marking your results. So, again, obviously we should recognize that that pair of characters represents one symbol. But hopefully the tokenization is nice and straightforward. Now here again, we run into this big long mess. Again, remember that underscores are valid as part of identifier names, so we should be recognizing that. Here it should be pretty obvious that we've got the logical and, the pre-increment and our identifier. So hopefully nothing here should be too big a surprise. Again, all we're worried about at this point is the tokenization. We're not trying to figure out anything about what this crazy program is actually going to try and do. So, there we go. There's part one. We've got our tokenization down. And now the tricky bit. What is that program doing? Now, I should probably have kept a copy of this before I went through and mangled it with commas, huh? However, the let me just write this out as let's say my Q1 answer. So I've got my original still available, and let's actually quit. I didn't mean to do that. Oh well. So we'll quickly go through and say, well, let me remove all my commas here, just so we can explain what on earth is going on. Let's find our commas and remove them. Get back to our code, albeit with a little bit of white space jammed in. All right, let's. Oops. Okay, take two. So now we've got our program here. All right. So I want to go through this and try and explain why on earth this might wind up returning 3. What kind of insanity have we got going on here? So I'm just going to go through and stick a few comments in and see if I can figure out what these different pieces are doing. So I've got this first function that's taking a parameter, and it's going through and returning whatever that is. It's doing a post increment on the parameter, adding to and returning it. Now, this is passed by value, right? So we've got this local parameter that we're going to do an increment on, a post increment on, after returning the value. Well, this is just a copy changing it does nothing as far as the rest of the program is concerned. So as far as calling f is concerned, what this is actually doing is saying, okay, well, you passed me some value, y0, and I'm going to return that plus 2. So really all f is just doing, practically, f is just returning y0 plus 2. So f is actually not doing anything terribly interesting. In function g, what have we got going on? So we've got these three variables, x3, y, and underscore z. So x3 is starting off at 45. Y isn't initialized, so it could be any old garbage. And we're setting underscore z to 45 plus 6. And we're adding 6 to x3 at the same time. So this is going to go through, add 6 to x3, assign that to underscore z, and y is just some garbage. So y is garbage. X3 and underscore z are 51 each, 45 plus 6. So now down here, what have we got going on? Well, let's see. We're getting f of y, so this is garbage plus 2, and taking the logical AND of that with a pre-increment on underscore z. So we're returning garbage plus 2 and 52. Right, we pre-decremented or pre-incremented z, which was 51, so it's 52. So we're taking the logical AND of some value plus 2, and so essentially garbage plus 2 is garbage. So we're taking the logical AND of garbage and 52. So G is either returning a 0 or a 1, right? Because it's returning the result of this logical AND. Right? So it's returning a false or a true. It would be 0 if the garbage in y just happened to be -2 initially. So if the garbage was a -2, then f of y would have given us a 0. So this would have, the logical AND would have been saying, 0 and something else is going to be 0. So it would be returning 0 if the garbage in y just happened to be -2. And G is returning 1 under any other circumstances. So there's actually two possible values we could be getting out of G here. But one of them is way more likely than the other one. So it's almost, it's pretty darn unlikely, not impossible, but pretty darn unlikely that y is just going to happen to start off at -2. But yeah, I guess it's conceivable. So what have we got in main going on then? In main, we're running f on g of 0. Let's see. G's not supposed to take any parameters. G doesn't expect any parameters. But since this is C, it won't complain. But C doesn't complain, just ignores the 0. One of the joyful side effects of C. So this is effectively, we're getting f of g where there's a tiny chance g returns 0, probably returns 1. So f has a tiny chance of returning 2 probably returns 3. So there we've got an explanation of what we think is going to happen. And we were told in the sample solution that it's returning 3, so, or pardon me, we were told as part of the question, since we were told it is actually returning 3 when run, right, no big surprise. The second scenario, the second more likely scenario is really happening. Tons of fun. So again, the idea is just to go through, kind of take these things piece by piece and say, well, what might be happening? Is there a way that I can explain this? Is there a way I can start breaking down this original ugly code and figure out what's taking place and explain it in some kind of rational fashion? So, tons of fun. I will leave that there. Feel free to explore and play with it a little bit. And we'll come up with a couple more of these for maybe some of the other 2016 questions.